Hi, everyone, and thanks so much for coming. I'm Joe Marcotte, and my teammates are Aaron Soggs, Josh Dudley, and David Davis. We would first like to thank Cameron from No Waste Compost for giving us this opportunity to work on such an important project to him and for being a great partner to work with. What is No Waste Compost? No Waste Compost is a local business in Burlington with the mission of reducing greenhouse gases through the practice of composting by providing customers with a designated compostable waste container. No Waste Compost provides a transportation pickup service that allows thousands of Vermont residents to compost their food waste and other organics. Their problem was that No Waste manages multiple databases by using several third-party applications, and their current setup doesn't allow customers to make changes to their compost pickup plans or customer requested cleaning services. This requires additional labor, as a No Waste Compost employee must make the changes manually to the database for each customer request. Our solution was to consolidate the No Waste Compost system into one central database, allowing them to offer customers more access to composting services as well as reduce their overall price for the services. Our tech stack was achieved by using Google Cloud Firestore database, Express JavaScript backend server, React front-end framework, Node JavaScript runtime engine, Stripe payment processing, Twilio text message reminders, and GitHub version control. Now let's go on over to the homepage. I was one of the 4 people who worked on this project, and my main duties were helping to implement the Firebase and integrating Twilio text message communication between No Waste Compost and their customers. I also helped to create an easy sign-up process that kept customers' experience in mind. To begin, the first step in the process was to create the database to store customer information. Then we could build out a form to capture customer information and write it to our database. Our form needed to collect the data, such as customers' contact information, the service area, and pickup plan selections. Additionally, we needed a way to authenticate our customers during the process of sign-in. To safely secure their account and data with this in mind, we had been working with MongoDB in class, but we ultimately chose to work with Google Firebase for its excellent authentication systems. Let's take a moment to fill out this form, and we will be using some test credentials. Now, one key aspect of the sign-up form was to limit the selectable pickup options according to the customer's location. No Waste Compost offers multiple different pickup interval and pricing combinations based on 5 service areas. When a new customer signs up on No Waste Compost's current site, they must move through multiple different pages just to specify their location, after which their service options are provided. This is just a cumbersome issue, and it elongates the onboarding process and provides a very poor user experience. To resolve this, we constructed the form so that it conditionally renders a customer's service options in real time based on the zip code they enter. Let's take a look at that. As if we enter the zip code 05401, the zip code for North Burlington, you will see that there are 3 available options. Now, if we go back and we enter 05404, the zip code for Winooski, we can see that the options changed to 2 options. Once the form is submitted, a new customer object is generated in our database, and we can export the customer's data for use. This brings me to another feature of the site, which is a text message reminder system, which alongside Aaron Soggs, we built using the Twilio messaging API. But for now, there's one more crucial aspect of the sign-up process, which is Stripe payment processing. For that, I will turn it over to my teammate, Josh Dudley.
Thank you, Joe. Hello, everyone. As Joe said, my name is Josh Dudley. In addition to working alongside my team members to set up the database and forms, I was responsible for styling the user interfaces of a large portion of the site, including the sign-in and sign-up forms you see here, as well as the landing page. I also set up a cloud function to generate CSV reports from customer data, which I will talk about later. However, my favorite and most crucial contribution to this project was fully integrating our database with Stripe, a third-party payment processor. As you will see in a moment, once this form is submitted, we will be routed to the customer portal where Stripe will collect the customer's payment. Before I do that though, I'll provide a little background for this. On the current No Waste Compost website, customers do not have the ability to update their subscription and pickup schedule on their own, as Joe mentioned earlier. If a customer wants to make changes to their account, they must contact No Waste Compost directly. This requires additional labor, as an employee is required to update the database manually for each customer request. Our solution for this was to integrate our database with a payment processing platform so that when a customer makes changes to their account, these changes are automatically reflected in Stripe and the customer is billed accordingly. Building out this functionality required a significant amount of documentation reading, both for Firebase and Stripe. Ultimately, I decided to configure a Firebase payment extension. To explain how this works, let's take a look at our database. So Cloud Firestore uses a NoSQL data model. In this model, data is stored in documents that contain fields mapping to values. These documents are stored in collections, which are containers for your documents that you can use to organize your data and build queries. Documents support many different data types, from simple strings and numbers to complex nested objects. Our database has 3 top-level collections, as you can see here: customers, products, and reports. And if we look into products, we see a collection of unique document IDs. These documents are references to products that we have defined on our Stripe account, which I will show you now. So on our Stripe dashboard, we have a list of products. Each one has a name, a description, a price, and a mode: one-time payment or recurring payment. Every time a new product is created, our extension generates a reference to that product and stores it in the products collection in our database, where it will be used to create a checkout session. This is accomplished through our extension's use of a series of cloud functions. Cloud functions take place in a serverless execution environment. They are single-purpose functions that are attached to events emitted from the cloud infrastructure and services and triggered when an event being watched is fired. In our case, the event is the creation of a customer in our database and generation of a checkout session. So let's take a look at our customers collection. When a new customer signs up, their information is collected from the form and written to the database. Firebase authentication system generates an ID for that user, and at the same time, our cloud function registers the event and creates a Stripe customer in response. These customers are linked through their unique ID. Our form notifies Stripe of the customer's selected product, and from there, the extension is able to generate a checkout session on the customer and route to the customer portal. So let's try that out now. As you can see, there are currently 5 customers in the database. And let's go ahead and submit the form. All right, and from here, we're at the customer portal. In the upper left-hand, you can see the chosen subscription. Using a secret API key and environment variables, we create a reference to Stripe here under the hood. Thankfully, Stripe captures the card information and is never stored on the client, so the portal is totally secure. And for now, we can use one of Stripe's test cards. Let's type in 4242, whoops. And once the payment is complete, the customer will be routed to their user dashboard. And if we look back into the database, we can see that a new customer has been generated. And back to the dashboard, one moment. We can see that the customer over here can update their subscription. This routes back to the Stripe portal, where they can cancel a plan, add a different payment method, view their billing history, etc. The extension can also be configured to allow one-time purchases in addition to their pickup subscriptions to allow customers to purchase other no-waste compost products, such as compostable liners. So that covers the Stripe portal, so I'll pass the torch to Erin to talk to you about the user dashboard.
Thanks, Josh, and thanks everyone for coming. I'm Erin, and my primary responsibilities for this project were helping to integrate and set up Firebase, integrate Twilio, and styling the pickup schedule and the user dashboard. The user dashboard was something that was important to our client, Cameron. He wanted to make sure it was something clean and easy for his customers to read, especially his elderly customers and people who may not be very tech savvy. This is why we left the styling simple so it wasn't too loud, and we also echoed the same color scheme that exists currently on the No Waste Compost site. As you can see, the user dashboard displays all of the user's basic personal information, as well as whether or not they've chosen a cleaning service, liner service, and notes that they'd like to add to their account. The most important part of the user dashboard is that the user is now able to update their own personal information. Currently, the only way a customer can update their information is by calling No Waste Compost and having an employee update it for them. This is because their customer's information does not live in one database. But now, if you click the update button, it redirects the customer to the page and they can update it on their own. Josh will demonstrate this by updating the user's address. So as you can see, it updates on the dashboard and it also updates in our database. And with that, I'm going to pass it to our teammate David to talk to you about our admin portal.
Hello, my name is David Davis. I was primarily responsible for creating the admin dashboard for No Waste Compost. The admin dashboard was made as a request in order to be able to analyze and check the information about various customers to make sure all information is correct, and this has multiple uses. To one, just make sure that every information is correct, nothing is out of place, and maybe there could have been an elderly user that might have mistyped something incorrectly. So there needed to be a way to make sure that all this information was accounted for. One way we can go about doing this is by searching for a user named Joe on his full name. And you can search for multiple fields: full name, email, phone number. You don't have to be particularly exact as long as you have a vague idea of what you're searching for, even when it comes to zip code. But if, as you can see every user named Joe. You could search through him for email. I'm pretty sure we have a Joe email. I can't remember if we do. But yes, we could search through zip code. This is could easily be expanded in the future to be able to edit this information directly from the dashboard, but at the moment, it's also pretty easy to edit in Firebase. This was primarily what I worked on throughout my project time, being able to implement this, but I would like to pass this now to my friend Josh, who will talk about generating CSV reports.
Thanks, David. And yeah, to round out our presentation, I'm going to talk a little bit about this button here. So No Waste Compost uses a third-party application called WorkWave to optimize their compost pickup routes. With the current setup, WorkWave takes in address data in CSV format, so we needed a way to store the customer address's data, address as a CSV file that could then be imported into WorkWave. To solve this, I built and deployed a cloud function that queries the database, downloads the customer data collection as JSON or JavaScript object notation, and then converts it to CSV where it is stored in our database. So if we press this Generate CSV Report button, and then take a look in our database, we can see that this report was just completed. Status will say processing as it's running, and once it's finished, it will say complete. So that one ran pretty fast. And if we take a look into our storage, we can see that a new CSV file has been generated. From here, it can be exported for further use. So that wraps up our presentation. We want to thank our sponsor, who has been an excellent partner throughout this process, as well as the BCA staff whose support and dedication to student success is truly incredible. Building this application was definitely quite challenging at times, but we learned a lot and are very proud of our final product. We're thankful for the opportunity to be able to help a local business that is doing so much good for our community. And thank you all for coming. If you have any questions for our team, please drop them in the chat and say hi in our breakout room.